All right, good afternoon. So today, like Dana said, I'm going to talk about transforming calculus with technology in IBL. So let me tell you about what I did this year. I've had this project in mind for a few years, and I decided, well, I'm going up for promotion. I'm having a baby, and we had a baby in April, or my wife did. I was just standing there, right, coaching her along, and actually applying for new positions too. And so I said, well, great idea, let's flip the class. Why not, right? So that's what I did this year, and I'm going to talk a little bit about what I did with technology, what sort of technologies I used, and then how I tried to incorporate some of the inquiry-based learning techniques that I learned from the MAA prep shop and from email correspondence we had afterwards. So the technology, let me make sure everybody knows what a flipped class actually is. So on the left, this is a Calc 1 class, and this is my traditional class. We meet 4 times a week. I lecture 3 of those a week. They have 3 homework assignments based on those lectures, and then we have a question quiz day usually. And we repeat 3 to 4 times, review, exam, repeat 3 to 4 times, review, final exam, end of semester. My idea was to keep this as close to this as possible. I didn't want to change it, just flip it. So the flipped class, what happens is instead of in class doing lecture, they come in and they work on sort of homework. So the homework problems basically I took from those homework problems. And then they screencast their lecture. So that's like their homework at home. They have to watch their video, and then they come in and work on homework. And everything else is exactly the same, right? So hence the name flipped class. So it's kind of nice. You just flip the homework and the lecture. Of course, you can't finish all the homework in class, so that was assigned outside of class, and they had like the weekend to do it, and I usually collected it on Monday. So how do you flip a class? I want to talk a little bit about this, so if anybody's ever interested, because you don't have to flip your entire class. I actually flipped 3/4 of the class the first semester, and I finished off the first fourth the second semester. But you could, the way I started this actually, I started doing homework assignments. I taught a college math class, and they were always very irate that I didn't have time to go over all their homework in class. So I said, fine, I will make homework videos. I made homework videos for every assignment. Never had a problem again. I don't know if that was a good thing or a bad thing, though. Right? They never asked questions again because they just said, oh, I could find it online, and I'm not sure if they actually accessed those videos or not. So I started basically with videos for homework. Then I made videos for reviews for my upper level classes like calc and stuff. And then I actually went into flipping it. So how do you actually flip a class? What do you actually need software-wise, technology-wise? These are the basics. You're going to need some sort of screencasting software if you want to do it on your own. So I use Camtasia because my institution had it available. Some sort of graphic art software. I use Smart Notebook because we have smart boards in most of our classrooms, and so this was on my computer. The tablet I had to buy, so a Wacom Bamboo tablet, which I'll show you in a minute, and then a microphone, and then a YouTube account is where I posted all the videos. Okay, so here's my YouTube page, and so my dream, one of my goals is to get every class that I've taught up here, and so I have, I'm teaching college algebra this summer, and so I have some college algebra. This is really great. I used to have some colleague cover my class, but now I just make a video. Right, and they watch the video, and that's basically that class that I missed for this conference. But on here, I wanted to watch, and I wanted to use YouTube so you guys can see the resolution.
To make a video when teaching mathematics, you will need several things. You will need a graphic art program. I'm currently using
Smart Notebook. This is sort of an explanation of how you make a
You will need
YouTube
a video screen capturing software. I'm using this Camtasia Studio 7. You will also need a microphone. So this is the microphone I'm using right now. And a tablet. It's also nice to have this screen capturing tool so you can capture whatever's on the screen and import it to your document. Of course, the tablet is nice because you can write any sort of mathematical expression like the integral from 0 to 2 x squared dx. Once your video is finished, you will want to open up your video screen capturing software and produce the video. So I'm going to produce mine in HD because I'm going to upload it to YouTube and I want it viewable on any device. So I let the video render, which will take a little while. Once the video is done rendering,
I'm going to stop this a little short since we lost some time, but basically I put it up on YouTube. It takes a matter of minutes, and it's available for anybody to watch, all over the world. And so it's actually rather simple once you kind of get used to lecturing into a microphone and with no audience. That's a little bit difficult at first. And actually the hardest part is when you make a mistake, you just got to keep on going. You don't want to go back and fix every mistake because you'll spend hours and hours trying to fix your videos to make it perfect. And it's actually okay if you make a mistake. You can always change the video next semester.
Notation. So
I want to see an
here's the
actual
notation
lecture
for a
video
limit. So we write the limit
here so you can see how clear it is.
as x goes to a.
Students watch this on their iPhones
Of
before
f of
class
x.
and take notes, or iPads. I mean, it's
And
virtually
so
like
let me
I'm
write
writing on
down
a
how you
whiteboard
say
in front
this.
of you.
So this is said the limit as x goes to.
Okay. So I think it's important that the technology is available so there's not too much loss, between my lecture. The only thing that's really lost is the jokes and the anecdotes, right, that I usually get. And I'm getting better actually online telling jokes and stuff, but it's not something I've really mastered yet. Okay, so that's sort of the technology component. Part of the class too, Google offers, they'll host your own site. And so I made a course webpage, which is really nice. One of the things that I hope my students do, especially the engineering students, once they leave my class, they often come back the next semester. They want notes, they want worksheets and handouts that I gave them for derivative rules and integrals and stuff. And so what I did for them is I simply posted everything on here, and I tell them, Newton's watching you. You better do your work. All right, so on here is basically the whole semester of calculus with all the videos and everything. So if you're interested in any of this stuff and you want to check it out, you can come here. I post the videos on here too. It's just a link to the YouTube page, but it looks real nice. They can come on here. And I post all the PowerPoints for them because a lot of the students, they don't want to copy down the graphs, so they print out the PowerPoints and then go on there and they can write on the PowerPoints and they just bring those to class. And I post on their homework up there. If they missed the day, they can actually look at what we did in class and stuff. All right. So that's the technology component. And then I do want to talk, though, about the IBL component, because that's why we're here, right? But that's a technology component. So the IBL, so this was a big question I had. Once I made the videos, what do I do with this class time that I have? I don't want the students to come in and just sit down at their desk, work their homeworks, raise their hand, I come around and I help them. I wanted to give them a better experience. I did not like the experience I was giving them. They liked it just fine. They were happy with what I was doing. I was not, though. I was getting tired of standing at the board, lecturing about the derivative, talking about the power rule, and turning around and seeing 5 or 6 people really engaged, but other people off in the corner just kind of sitting there looking out the window. And I wanted to do something that they would be forced to be engaged in what we're actually doing. So what I did, and I call this the mathematical exploratorium. And the reason why this is because my real goal is sort of change the way that students think about learning mathematics or learning in general. So the Exploratorium, if you don't know, is a science and a museum and technology museum in San Francisco I used to go to when I was a kid. And so when I was trying to think of something that resembled what I was doing, I thought this is like a place where we explore mathematics and we do it differently on different days. And the way this is set up, the way my classroom is set up is basically they come in and they cluster into groups of 5. And so usually I like to have 5 groups of 5 if I can. I have whiteboards around the room, and I split those whiteboards up into 5 sort of spots where the students go. And I have a smart board in front. So the students will come in, and they'll sit around at their seats, and I'll basically kind of review a little bit, lecture a little bit, like for 5 minutes or something, to say, hey, here's what we did. Here's what you did on the video. Sometimes I give them a video quiz, just to try to help them remember to watch the video. And sometimes I do some enrichment stuff, some historical stuff, maybe an activity that a problem a little bit harder that's kind of interesting. But just 5 or 10 minutes, because I really want to get them to work. And what I have them do, I'm going to give you guys an example of a homework. So this is out there. So at your table, if you look, you'll see a limit sheet. And if you don't, scoot down, because I only had a few of these. These are actual sheets. And I want you guys to see, I didn't have time to create new homework assignments. I simply took my old homework assignments from my traditional class, and I just brought them in to this class. And you might have to move down closer to somebody, because I only had about 8 of these handouts. And so this is just a simple limit assignment from WebAssign. I copied it off of there, and they'll sit down, and they'll basically go to the board, and they'll work these problems. 2 people will go up at a time, and then they'll sit down, and then 2 more people will go up. and then they'll sit down, and then we basically will stop at a certain point. Right? So the idea is that everybody's working in some sort of continuous fashion. Nobody's can really just sit there and do nothing. And so it's like basically, you kind of see 2 go up, 2 sit down, 2 go up, 2 sit down. And then there's usually a stopping point. And the stopping point depends on the homework problems. It depends where the students are at if they're stuck. And so, because we'll stop at some time and basically compare and contrast. We only have so much whiteboard space also. But we compare and contrast. And this is the best part. So I need 4 volunteers. So maybe 2 over here and 2 over here to come on up here. I just need you to hold a poster. That's not hard. All right, so come on up. I just need 2. I want you guys to see what this might look like so you can experience it. Because it doesn't have to be, so grab. So I need someone back here to grab this one. And then there's one more underneath it. Dana here. Grab this one here. Yep. And then, yep. Maybe one more person. Oh, there we go. Dana's got it. Okay. So, yeah, I got it. So hold up. This is what it would look like if you came into my classroom. And this is number 7. So they've done a few of these already. And what we would do, they'd put them on the board. And I'd stop class and say, OK, let's talk about these solutions. And something I might say, which I've never been able to say before, which I think is really neat, is like, well, which one do you guys like the best? And it's hard to see because that camera's in the way. But which one do you like the best? And they're really good at picking out the best one. And so they usually will say either the 4th or the 5th down here. And a lot of them will say the 5th because it has everything in it. And we can go through these and we can talk about things like, why don't I like this solution as much? Now, I don't know if I take off, but there's things I don't like about it. We can talk about why this is not really equal to that without the limit sign. I see this all the time. The limit of this goes x negative 5 of what equals that. It's not bad thinking, but it's wrong notation. So we can talk about it. Here, there's missing some equal signs. Again, equal signs are a big deal, I think. It's the difference between my A and C students and definitely my A and D students. A students always write equal signs. Right? There's nothing. People come in and ask me, what are my issues with math? And I look for equal signs. I'm like, write equal signs. Try equal signs. Maybe that'll work. Because there is no answer, right? There is no real answer if you're having some problem. You don't know. But I do notice patterns, and I notice they don't write equal signs. And so you can go through each of these and tell them what you like and what you don't like. Now, they're 2 at a time, and nobody remembers who actually was at the board because there may be 3 more problems up there. You can also compare and contrast problems before. Right? So they had a problem before this that was very similar. So you can say, how are these similar? And then students can tell you, well, you plugged in a number, you got 0 over 0, which is indeterminate form, and then and the last one, the one before, you factor the top. How's this one different? Oh, you have to factor the top and the bottom. And there's a problem after that one's a little bit more complicated. Also, what's really nice about some of the web assignments, all the numbers are different. Right? And so at the end of this class period, I maybe get through 8 or 9 different limit problems. But they've actually seen, if there's 5 groups, they've seen 40 to 45 problems with different numbers. Now, same types, and then we can talk about the types and stuff like that. But I really enjoy this sort of exercise. All right, thanks, guys. Thank you so much. You just put it down. Don't worry about it. Thanks so much. You can step on it. Don't worry about it. I step on it all the time. I was stepping all over my room. Okay, so this is sort of the comparing, contrasting idea, and we do this, 3 days a week. They come in, and whatever we don't finish is basically assigned for homework. Okay, so that's a traditional problem set. So most of the homework sets are traditional, but I have a few discussion-based. These are always very, very interesting. Most of you guys have a handout of the discussion-based problems. Now, on this one, I don't have them jump up, okay? So most days, I'm like, real time, people, real time. That means get up at the board, real time. You're working these real time. Don't sit there and work them out and get up the board. But when they do discussion-based problems, they do sit down, and they're all together. They talk about it, and then they write up their answers on the board. And then as soon as enough answers have been put up there, we'll stop, and I'll talk about them. And what's really interesting about these is you get to have some discussions that I've never had before, except for with myself, on what are the issues, what are they thinking. So here are some of the things they put up, and it turns out that none of these are actually right, except for mine in the middle. And so what I would do is I talk about them and say, hey, great, these are wonderful wrong answers. They're the best wrong answers. I see these answers all the time, and let's talk about why they're wrong. Let's talk about what this actually means and what it's actually saying, and why it's not correct. And so it's a really great opportunity to kind of get them to see mistakes that are commonly made, and hopefully they won't make them again. Now, it does take a long time for these discussion-based activities, longer than I thought. It's a lot easier to do the traditional type of activities. For the theoretical problems, I gave a handout. The theoretical problems always involve the word proof. Right, so prove this, prove that. In a Calc 1 class, most students aren't ready for a proof type question. If you're interested in this, you can talk to me after the talk. But basically, they need a lot of help doing these sort of proof-based questions. I wanted to get to some of the activities, because all these things, these are just traditional assignments I kind of had on hand because I didn't have time to make new assignments because I'm making videos. And these are like quizzes I had that I tried to change into more IBL sort of active learning activities. So I'm going to look at the derivative relay, which all of you guys have. It's quiz, let's see here, it's quiz 6. So if you look at quiz 6, this is a really fun activity. So in this Calc 1 class, of course, one of the most important objectives is learn how to take the derivative. And it's actually really hard at first, I found, to get students to learn how to take the derivative. There's some resistance to it, even though it's differential calculus is probably the main part. So what I did with this, and I call this the derivative relay, because it's sort of a relay. What I do is I cut this quiz up. It's basically printed on 2 pages. I cut it up and then 5 pieces, and I lay them down. There's a table in front usually, and I lay them out, and they have these note cards on front of them. A, which the answer is on the back, B, C, D, and E. And their job is they have to work alone. I tell them, okay, here's how it goes. You're going to come up. You're going to take a quiz question from A, go back, sit down, do it, come back up, check your answer. If it's right, you get to move on to part B. And the answer is on the back, no solution, just how it's supposed to be written. And then they move on to part B, and they move on to part C. What's really great about this activity is all the people that can take the derivative finish, and then they can leave. Because the issue I have is if I try to do this in groups, is that the people that can know how to take derivatives, they simply tell the students that don't know how to take derivatives. And so this one involves basically the power rule, product rule, quotient rule, and chain rule. There's a lot of algebra in it, and that's where they really struggle. And so it's a really great activity. Those that know how to take the derivative, they get to go after they're done. And then I'm left with the people that are struggling a bit, and then we can group up a little bit. And I have them group. And if they can't do it still, then they get to take it home, and they can come and ask me and stuff like that. Of course, I don't tell them that at the beginning. In the beginning, I just let them go, and I say, it's on your own. And then when everybody, 6 or 7 people are gone, I'm like, I'm looking around, people are struggling. I'm like, let's group up. I'll have them group up and do it. And then then at the end, I'll say, those left, why don't you take it home? Come by my office. We'll work on it and stuff like that. And then the second one, which I've been doing for a while now in my Calc class, and I like this one an awful lot too. This is one of my favorite ones. It's an optimization problem. So after we do optimization, and optimization is interesting to do in a class. I mean, imagine doing an optimization problem on the blackboard and you have 5 of them going at the time, So I have them do them in pieces, that 2 people do the picture, the next 2 people do the equation, and they have to really collaborate, which is really interesting. Those people doing the picture, they're up there, and then maybe the people at desk are doing it a little bit differently. And then they have to come together and they have to actually talk and, and say, okay, this is what I always do, and they have to interpret their picture and stuff. So it's a really interesting sort of process. But this they do in groups, and they're in their groups of 5. And this one's fascinating too, because first they have to figure out what's going on. And basically you have some rectangular paper, I think it's 24 inches, is a perimeter. You fold it 3 times to make a rectangular tube. What's the maximum volume you can get? Okay, so they got to figure out how to do this. And they label the picture, and some groups label it like I did with X's here, and some groups call it X like that. And about 10 or 15 minutes into the activity, when they're kind of getting going, I tell them, all right, why don't you collaborate with other groups, not just your group. And then they realize that some groups called this thing X, and some groups called this X. Which one's right? And so it has a great sort of creative aspect that shows you that mathematics is creative, and it doesn't matter which one you call X. Right? They both solve the same problem, it's just a different X. And then at the very end, what's really nice is they have to build this thing. And they're engineers. A lot of them are engineers or scientists, They have basically a piece of paper, and they can tear it, and they have a ruler, and they have some sticky dots, and they have to construct this actual rectangular tube. And it's really interesting to watch them construct this and how they do it. They measure 2 inches, 2 inches, 2 inches, 2 inches. They don't think about folding it in half and folding it inside. They don't think about putting the stickers on. Watching them put those stickers on, they try to open it up and they try to put those stickers on like this, instead of talking about you just lay it flat. And so we get to the discussion about talking about not just that you can solve the problem, but how do you solve it? How are you going to come up with this? Is it the optimal way to solve the problem? Thinking outside of the box, really. And then, of course, this was really a transformative experience for me. You can see, not all of you know this, you become less of an authority, more of a coach, teacher. There's no passive learning, active learning. Static classroom to dynamic. This classroom's alive. Retention rates are great. It doesn't change grades, but I like it. I was not happy. The grades are basically the same. The only difference is, you imagine the A's, what happens to the A's? They go up, right? And some of the B's go up to A's, but those people that I was really trying to get the D's and maybe the low C's, they didn't move much, But the creative possibilities are endless, and the best transformation is I get to say, every day, what a wonderful mistake. And at the end of class, I get to say, great job, guys. You did an awesome job. And, you can lecture. I'm saying lecture. Good job listening to my lecture guide. And it doesn't work, But this works, right? Had a few high fives this year and even had one fist bump. I never fist bumped in my life before, but I fist bumped the student, on a correct solution. So it was a really good, wonderful experience. And if you're interested in it, you can contact me. This is my email. And here's my website. So if you want to look through anything that I have, you can go there, my YouTube page. And thank you.